I'm very happy to be here. Today I would like to introduce maybe our own situation to you, maybe different from majority of you. But anyway, when I first heard about EVE by Professor Masaki Sato, he's here, the University of Tokyo professor. I wonder what it would be. But Bjorn Stevens sensei visited to Japan in this spring, and he gave a very, very impressive talk inside JAXA. He visited to JAXA. Today he is wearing JAXA's T-shirts. So thank you very much. But anyway, his talk was so impressive. And many of my colleagues after your talk came to me virtually, someone, but so interesting and impressive idea. Okay. Anyway, I myself, because of that, I decided to come here. Okay, thank you. Maybe I forgot to click this one. Okay, being different from European people, so for us, when we face to every year's severe storm, the severe heavy rainfall, we feel climate change every year like that. And that is very not climate-like but weather-like phenomena. Okay, and according to the UN ESCAP report, resilience in a riskier world, Asia and the Pacific has accounted for 57% of global fatalities from disasters and 87% of the global population that has been affected by natural hazards since 1970. And also, another report, ESCAP Asia Pacific Disaster Report 2019 said the overall number of disasters is on an upward trend, largely towards an increase in the number of climate-related events and the related environmental degradation. For us, anyway, we have a lot of rainfall in Japan. So providing timely and accurate information on monitoring of precipitation by satellites helps countries, not only Japan, and communities build greater resilience against floods, storms, and other hydrometeorological and climatological hazards and extremes. I, anyway, came from space agency. Let me mention the features of Earth observation satellites. The good things. The first point, satellites can provide data from local to national, regional, and even global. And the long time series and continuity. Comparing to the climate something, still the data record is shorter, but already we have 20 years or 30 years data record of satellites. And consistency and comparability. And the fourth point is diversity of measurements. Not only very physical atmospheric something, we can obtain the information of, for example, bio something information like vegetation and red tide in ocean and like that. And environmental change have been observed by satellites, Earth observation satellites. And the fifth point is complementarity with traditional statistical methods. And here is the list of Japanese Earth observation satellites other than geostationary meteorological satellite by JMA. JAXA currently operates 6 Earth observation satellites or sensors on orbit. So these satellites monitor cloud aerosol, vegetation, greenhouse gases, water cycle, precipitation, disaster, forest, and so on. So especially, so JAXA has accumulated vast experience of L-band synthetic aperture radar instruments for more than 25 years since JLS1 to address social challenges through the forest monitoring, disaster monitoring, and so on. And also, JAXA has been developing and operating the Advanced Microwave Scanning Radiometer, AMSA series we call. The data from GCOM-W AMSA2 launched in 2012 has been utilized by many members of CGMS, including UMETSAT, NOAA, and JMA. So, and also for precipitation radar, we have also a good continuity from TRIM to the current GPM. So, and this is another example of decade-long observation by GOSAT. So regarding the GHG observations, the Japanese greenhouse gases observing satellite, GOSAT, was launched as the world's first GHG dedicated satellite in 2009. Since then, GOSAT has been monitoring changes in atmospheric carbon dioxide and methane every 3 days globally. And it frequently targets more than 50 large cities to monitor major anthropogenic emissions. GOSAT-2 was launched in 2018. In addition to the same carbon dioxide and methane observations as GOSAT, it has a sensor capable of observing carbon monoxide. So, so satellite observation can contribute to the advancement of climate change predictions through process studies. So improved predicted information leads to applications such as climate change adaptation in so in various areas like this. So, and we can cover land observation and atmosphere, ocean, and cryosphere. So, and so many informations from satellites. So, and next, what I want to introduce is the precipitation map. So, we means JAXA generates called GS map, global satellite mapping of precipitation in real time. So currently, so and this is this is the same idea as the United States NASA's IMARCH. Okay, so and the grid size is 0.1 degree. That means around 10 kilo gridded data, and that good point is real time. So and open, this data is open and free. So and yeah, because precipitation itself is one of the difficult physical parameters to forecast. So and to monitor the direct observation should be very effective, we thought. So to generate this GS map, we are using several, nearly 10 microwave sensors from all over the world. And then the key role is by the GPM satellite. GPM has NASA's microwave radiometer and JAXA's radar together. So, and that is a kind of standard to calibrate other several satellite data. Okay, so again, the GS map movie. So please take a look. So we are using several satellites. So because we have this GS map product, so we have started the conversation with Professor Masaki Sato and also the Dr. Miyoshi of Riken. They are the model developers using NICAM model, and then they started to think about assimilation to maximize the use of satellite data. So many of them, so JMA, of course, uses the satellite data, but to introduce a new method or new data, of course, they are very, they cannot challenge the new things so easy because they cannot stop the operation. So, and then in research base, we started the collaboration with NICAM modelers. So, so, okay. So before going the modelers, so I forgot to introduce this one. So GS map itself is very useful, especially for the countries and regions where they don't have enough precipitation data. So we visited actually in real to the islands over Pacific. So they recently started to use the GS map data for their monitoring of precipitation like this. So many Pacific and East South Asia countries, the meteorological department are using like big monitor to show the GS map. Yeah. This slide is the modeling thing. So JAXA, University of Tokyo, and Riken installed the NICAM LETKF data simulation system using the GS map at JAXA Supercomputer System Generation 3, JSS3. And has experimentally operated it in near real time. So the research actually started 10 years ago about. So but the timing of the data opened as recent. So 3 years ago. So this page you can check from here. So the information includes the 5 days forecast. So you can you please check. And this is the NEXRA weather simulation in JAXA supercomputer system. So the color shows surface skin temperature, and gray colored shows outgoing long wave radiation. So we are operating this in JAXA. So the next model I want to introduce is the system name is Today's Earth. This is the global hydrological simulation system jointly developed by JAXA and University of Tokyo. So it outputs various physical variables and risk indicators related to water on land, making maximum use of satellite observation such as GS map and solar radiation from Himamari as atmospheric forcing. So the hydrological model, no. こっちだ. hydrological model using satellites. And currently, the spatial resolution is 50 kilo for land, and for river, the 25 kilo. So, and we have two versions. One is global, another one is regional. So, and so because the reason why we developed the Japan regional version first is Japan is too small to express the rivers by 25 kilo. We cannot see anything. That's why only for Japan we firstly make 1 kilo model. So the difference is like this. So, and the purpose is different. So this is for regional flood forecasting, reduce response time to disasters. But the global is for climate service for evaluating future risk. So we are using two different models. So, and the final goal is, so currently we are preparing 10 kilo version for global. So, and this year or next year, we have a plan to release. So, and the goal is global 1 kilo. So maybe we will take several years more than. So, and then, so for applying the JMA's weather forecast precipitation to this 1 kilo model, so so it is possible to estimate flood risks more than 30 hours in advance in Japan region. So in the Typhoon Hagibis in 2019, more than 90% of the dike break points could be alerted in this system in advance. So, so this is the global. This is the example of runoff animation. So, and so this is the 1 kilo version of today's Earth, the Typhoon Hagibis case. So the typhoon from moved from south to north. So, and the alert, the cross mark indicate alerted point, and the actual dike break occurred in the red pinpoint version, pinpoint points. So, and the 90% of them are already predicted. Yeah. So, and today's Earth is, of course, this is the case of the severe drought in Europe last summer. That this is a soil moisture anomaly. So, and situation around us here. Okay. I try to summarize. So we just started conversation with users, including private sectors who are interested in climate information and or satellite observation, to promote satellite data use in Japan. So anyway, your visit was a very good opportunity to accelerate our activity. So, and we introduced the Earth Digital Twin idea, and so high expectation from users. So they are saying, a very nice idea. So they want to use, they say. Okay? So, and however, image to Earth Digital Twin is very varied indeed among them. Okay? So, so some people think about the Earth scale digital twin, but many of them think of very city or urban or very, very small scale digital twin they are thinking. Okay, so, and that's why we think we need for high resolution data. Okay, so, and also some people are thinking, so kind of data record something, past historical data record
if he clicks somewhere, not only the data itself, but also the very historical images or photograph or sometimes 18th century something, for example, disaster record or something, if he could get those everything, it would be happy, he said. So, but not only him, some people are thinking kind of data record, not the operational or, and of course, another type of person are thinking the decade or more future climate something. That is the majority, I think, in Europe, but in Japan may be different. So, and also, we have recognized that user interface to access the information from the Earth digital twin is the key and the difficult point through the conversation in Japan, because they want to do something, so, and so many requests. So what kind of interface? That is the very big challenge, we think. So, and also, if we say information, there are so many different levels of information. So that is also a difficulty. Anyway, how to extract information from various kinds of huge amount of data, that is our current challenge, I think. So, but in this meeting, there are so many ideas already. So in Japan, maybe users have not noticed there are so many big data, not yet. That's why I think. So, and development direction, JAXA's case, this is. So this morning I added this slide by myself, so that's why not so sophisticated. But so from the user's voice, we have to think about to cover the past, present, future. If we say maybe the data assimilation operational type systems I introduced today. So using no. So our JAXA's development target is still the present and monitoring the purpose is here. So and also currently the model is has been developed partially. Partially means atmosphere part, ocean, and hydrological. But in the future, so those will be integrated as Earth system model, maybe. So, and that is the kind of direction. And also, so currently, the global, since now, the users or developers are from government or academic. So, but in Japan, many municipal, I cannot pronounce this one. So, but private companies and the individuals are interested in. So, and to cover that area, so maybe the local to city, urban, the small size of digital twin we need, maybe. So, and to do so, so already, so the target is high resolution. So global 1 kilo, but finally to reach this request, maybe at least 100 meter or 10 meter, like that. So maybe we'll move to those regions, I think. Okay, so and this one. So, and this is a kind of summary. So we are developing data assimilation type of systems. So today I didn't introduce, but we are developing ocean models and aerosol models also. So, and maybe together with digital twin of the Earth. So, and then also observation data lake will be important because today model cannot generate, not still everything. So only information only from observation, maybe we will put besides. So, and also in Japan, IPCC research modeling research group is exist. So so they are different. They they are in the different project. So but that is the maybe the original majority of climate service something. So and then maybe I already said the same thing. So but anyway, many activities relating to climate informed services in Japan. So thinking the user accessibility to information, at least more linkage in Japan should be considered. So we are still not so talk each other, but in the near future, so after going back to Japan, maybe with Professor Sato and the Riken researchers, we need to start more conversation. Yeah, thank you.